Hey everybody, by the end of this video you should be able to write scientific notation correctly and be able to interconvert between standard notation and scientific notation. Now on this first page here, you'll notice that I have two terms that I made in my intro. The first one is standard notation and the second one is scientific notation. Now, just so you know, standard notation is the fancy way of saying plain old numbers. So the number 1 or 32,650,000. That's a number in standard notation. Or 0.000693. Again, all numbers in standard notation. Any number that you write out is a number in standard notation. Scientific notation is a way to take very big numbers like this one, or very small numbers like this one, and put them into a form that you can understand. So scientific notation is a number like 3.265 times 10 to the 7th, or 6.93 times 10 to the minus 4. And actually, these two numbers are this number and this number represented in scientific notation. Now, a couple of things about scientific notation before we begin. There are some things that you need to absolutely know have to go into a number in scientific notation. Both of these numbers have these things out in front. The numbers in front are called coefficients. Okay, so the numbers out front are coefficients. And then you will always have a times 10 to the, no matter what, and then you'll have this in the circle. And that is the exponent or the power. So it's going to be coefficient times 10 to the exponent. That's always the form of scientific notation. No ifs, ands, or buts. Okay. Also, when we're talking about the qualifications of each of these, a coefficient must, if it's in proper scientific notation, must be between 1 and 10, 9.9999999. Okay, a lot of times you'll see me say 10 just because it's easier than saying 9.999999999. So coefficients have to be between those two values in order for it to be in proper scientific notation. These two numbers I have written in proper scientific notation. And the exponents can be anything from negative infinity to positive infinity for proper scientific notation. Now, if I'm going to do this the way that I want to, I should spend some time talking about how scientific notation works, or why it works the way it does. So the thing to do is start with a number written in standard notation that we know about, that is easy for us to see, and that's 300. Okay, if we start with a number like 300, now scientific notation works because we are removing powers of 10. So 1, 10, 100, 1,000, 10,000 on down the line, or even 0.1, 0.01, 0.001. So that's the way that scientific notation works. So what we are doing is we're writing this number as 3 hundreds. Okay, and we know that 3 hundreds can be written as 3 times 100. And 100 then can be 3 times 10, the power of 10 squared. Okay, so that's how this works. Okay, and it works for any value, any number. And the point is to get a coefficient that is small enough for us to be able to manipulate in our head. Numbers can only be manipulated up to a certain amount. Our brain can only handle numbers that are so big and so small before it gets ridiculous. Okay, so this can work with any number. Okay, so if we take 0.00 3, for example. Okay, that is 3 times 10, or sorry, let me do it in the same order. It's 3 thousandths, right? Which we know we can write with a multiplication. And 3 thousandths is 3 times 10 to the minus 4. Okay, so that is going to, I'm sorry, 3 times 10 to the minus 3. What am I doing? Walsh, 3 times 10 to the minus 3 thousandths are, right? Okay, so it works by separating out all the values of 10. Okay, that's really what we're doing in scientific notation. So I have some practice problems for review, so you guys can look at it. Now you can do these one of two ways. You can either pause the video and work through them, or you can watch me work through a couple and then pause the video, or you can just watch me work through them all. Whatever you want, however it's going to let you do the video. Now, I'm going to show you my method for determining or for writing numbers in scientific notation, and that's fine. Okay, so this first number here doesn't have a decimal point, so we have to add a decimal point. You learned in elementary school mathematics that if a number doesn't have a decimal point, it's immediately to the right of the last number that is written. Okay, so what we're going to do is we're going to move the decimal point, the number of spots, so that we end up with a number that is between 1 and 10. Okay, so that's what we did. Okay, notice we've gone to 4 billion something to 4.895. So now we're going to put our times 10 to the, and now we just need to determine the power. Well, the power is determined by how many places you move the decimal point. 1 billion, or a billion, is 10 to the 9. Notice we moved the decimal point 9 places. I guess I could show you each place. 2, 3, 1, 2, 3. So that's 9 places. So that's how you write this in scientific notation. Now here's a number with a decimal in it. So we're going to take that, and notice that this is a very, very small number. So we're going to move the decimal point again until we get a number that is between 1 and 10, 7.23. Some students have a tendency to move the decimal point all the way to the end. That is not right. Don't do that, because that's going to give you 723 as your coefficient with your decimal point, and that number is not between 1 and 10. So that's not the way you can do that. Okay, so you need to put it in between the first and second non-zero digit. Okay, so we set up our times 10 to the, and now how many places did we move the decimal point? 3, 6, 9, 10. And so now, because it's a small number, minus, we do it to the power of negative 10. So that's 7.23 times 10 to the minus 10. Okay, now there's some other interesting ones. These two previous examples will work all the time. If you do it the way that I did it, it will work all the time. Okay, but there are some that we attempt to try to fool students with as teachers. And so here is the first one. You'll see that this is 2.87, and you say, well, Mr. Walsh, this thing is already written as just a number between 1 and 10, right? But we want to write it in scientific notation. So it's 2.87, and because the number's already between 1 and 10, the coefficient is. And so now we still want to do times 10 to the. And so times 10 to the, and how many places did we move the decimal point? None. So it's times 10 to the 0. Okay, and so you may see something like 32. Again, it's a small number. It's a number that we can manipulate pretty easily. We can do stuff with. So why do we need to do this? Well, there are certain times when we just need to use numbers in scientific notation. So again, we're going to take the decimal point, we're going to put it here to the furthest right, and then we're going to move the decimal over 1. 3.2 times 10 to the first. We moved it once. Here's a single digit number. Okay, so this one's going to be like this, which in turn is just like all these other ones. Okay, put the decimal in if it's not there. Okay, and then we assume that, no, sorry, we don't assume. That number's already between 1 and 10. So we're going to put 5 times 10 to the, how many places did we move the decimal point? None. Okay, so now we keep going here. Okay, move the decimal point 3, 6, 8 places. So this is 5.87 times 10 to the minus 8. And that's that one. 3, 6, 9, 12, 13. 8.9 times 10 to the 13th. Notice here I didn't put the decimal point in because when I do this enough, I kind of already know where the decimal is. And so I don't need to draw one, and if you understand where it is, you don't need to draw one either. Okay, so now here's one that confuses people. These next two confuse people all the time. Okay, so it's 10. Now, while 10 is a power of 10 all by itself. Okay, so it seems like it's already in scientific notation or whatever, and then I say, well, and then you say, well, Mr. Walsh, the coefficient has to be between 1 and 10. Well, actually, it has to be a single digit. No, it has to be between 1 and 9.99999. So 10 actually can be written, if we put the decimal point in there, we move it over 1, so now we get 1.0 times 10 to the first. And that's how you'd write 10 in scientific notation. Okay, 1, again, 1 is going to be just like this and this. So 1 is 1 times 10 to the 0. Notice the difference between the two. This is 10 to the first, 10 to the 0. Okay, and then 0.5, move the decimal place over that way once, so it's 5.0 times 10 to the negative 1. Okay, so hopefully you got all those right. Let's move to the next one. Okay, going from scientific notation to standard notation. And I find that this is a little easier, so I have less examples. There's a couple of strange cases here that we'll talk about very briefly, but here we have 3.45 times 10 to the third. Okay, well, from our previous example, what we know is that the power, the exponent here, is how many places we move the decimal point. So 10 to the third is a big number. If you forget, I try not to say move the decimal point one way or the other, but if you forget which way to move the decimal point, what is 10 to the third? 10 to the third is 1,000. So this is going to be 3 thousands. So here's what I would do. I would move the decimal point 1, 2, 3. So it's 3, 4, 5, 0. 3,450. Now, here's times 10 to the minus 6. And that is going to be, let's see, tens, hundreds, thousandths, 10,000, so it's like millionths. Okay, so that is 10 to the minus 6 is millionths. So that's going to be a small number. So we're going to move the decimal point toward the left. Okay, so let's do this. Let's see, 1, 2, 3, 4, 5. I'm going off the screen. 6. Okay, so now every place we put a little bump, we put zeros in, and so here's what it's going to look like: 0.000000846. Okay. 10 to the second. Okay, 10 to the second is 100, so this is going to be 947. Okay, 2 plus spots. Okay, so here's a 10 to the 0. Okay, well, how many places do we move the decimal point? None. So this is going to be 2.8. It's fine. Okay, we're almost done. 5.772 times 10 to the minus 3. Okay, move the decimal point over 1, 2, 3 spots, put a 0 in the decimal point, so we get 0.005772. There it is. Okay, now these strange cases act the same way, and it's not strange cases because of the number, but it's a strange case because of the coefficient. Sometimes you will see coefficients that are written not between 1 and 9.99999. Okay, there are certain cases where that is necessary to do or easier to do, but these are not written in scientific notation, not psi notation. They're not scientific notation. So this is not proper scientific notation. This is what we would call exponential notation. It's just a number written as a power of 10. So it's not scientific notation. But again, it may be easier to use these sorts of numbers doing calculations or trying to compare values. So that's what this is. So if you wanted to, though, you can definitely put these into standard notation. Okay, so this in standard notation, 1, 2, 3, it behaves just the same way, 0.010945. That's that. And here's another one that's less than 1. So now this one is going to move the decimal point over 5. So it's 1, 2, 3, 4, 5. So that's going to be 68,000. Okay. And so that concludes the review video on how to write in scientific notation and interconvert between scientific notation and standard notation.